Hi, my name is David Park. My chemistry summative is water treatment. Water treatment describes those processes used to make water more acceptable for a desired end use. These can include use as drinking water, industrial process, medical, and many other uses. Sewage treatment or domestic water treatment is the process of removing contaminants from wastewater and household sewage, both runoff, effluents, and domestic. It includes physical, chemical, and biological processes to remove physical, chemical, and biological contaminants. Its objective is to produce an environmentally safe fluid waste stream or treated effluents, and a solid waste or treated sludge suitable for disposal or use, usually as farm fertilizer. Using advanced technology, it is now possible to reuse sewage effluents for drinking water. The first strategy that will be used to purify water is chlorination, which is the connection is the equilibrium of weak acids and bases. Chlorination is the process of adding the elements chlorine to water as a method of water purification to make it fit for human consumption as drinking water. Water which has been treated with chlorine is effective in preventing the spread of waterborne disease. The chlorination of public drinking supplies was originally met with resistance as people were concerned about the health effects of the practice. The use of the chlorine has greatly reduced the prevalence of waterborne disease, as it is effective against almost all bacteria and viruses as well as amoeba. During this process, the concept of the greater equilibrium of weak acid bases were used, which is the dissociation of an acidic or basic compounds in an aqueous solution produces ions that interact with water. The pH of aqueous solution is determined by the position of equilibrium in reactions between the ions that are present in solution and the water molecules. When chlorine is added to water, it reacts to form a pH-dependent equilibrium mixture of chlorine, hypochlorous acid, and the hypochloric acid, which is the equation of Cl2 plus H2 to H2Cl plus HCl. Depending on the pH, hypochlorous acid partly dissociates to hydrogen and hypochlorite ions, HCl to H plus Cl minus. In acidic solution, the major species are CO2 and HCl, while in alkaline solution, effectively only Cl minus is present. Very small concentration of CO2 minus, CO3 minus, CO4 minus are also found. The second connection is to use law of solubility. Bringing air into intimate contact with the water for the purpose of exchanging certain components between the two phases is called aeration. Oxygenation is one of the purposes of aeration. Others are removal of volatile organic substances, hydrogen sulfide, ammonia, and volatile organic compounds. A gas or substances dissolved in water may further react with water. Such a reaction is called hydration. Ionic substances dissolve due to hydration, for example, HCl gas plus the number of water equals to H2X plus Cl aqueous minus. H2S equals H aqueous plus HS aqueous minus. The last connection is intermolecular forces in liquids and solids. Even after secondary treatment and filtration, soluble organics may still be present in the wastewater. These remaining materials are called refractory organics. The most practical way to remove the refractory organics is by adsorbing them on activated carbon. Adsorption is the accumulation of materials on an interface. In this case, the liquid-solid boundary layer. Carbon is activated by heating in the absence of oxygen. This activation process creates many small pores in each carbon particles. Activation thus increases the surface area of each carbon particle, making it more effective as an adsorption agent. After the adsorption, the capacity of the carbon has been exhausted. It can be restored by reheating in the absence of oxygen. The process drives off the adsorbed organics, which can be consumed in an afterburner. And thank you for listening.